Good morning, student. First of all, I want you to note that atomic number of fluorine, atomic mass number of fluorine is not 18, it is 19. So since it is 19, it is the odd, and from our table we know that odd combination have I value greater than 0, and that's why your fluorine is NMR active. So we start with our today's topic, that is interpretation of NMR spectrum. So NMR spectra is interpreted on the basis of 4 points, that is how many number of peaks are obtained in the spectrum, that is number of peaks, what is the position of peaks in the spectrum, next part is what is the intensity of peaks in the spectrum, and what is the splitting pattern of your signal, that is a peak. So we start with our first topic, that is what is number of signals. Before going too deep into the topic, we first have to know that what is mean by equivalent proton. Equivalent protons means the proton which are present in same chemical environment are called as equivalent protons. What are non-equivalent protons? Protons which are present in different chemical environments is known as non-equivalent proton. Now, what is the significance of equivalence proton? That a group of equivalent proton absorbs at same frequency. It is important. All equivalent protons absorb at same frequency and give single peak. So now we are going to see how we are going to find out equivalent and non-equivalent proton. So we are going to find out equivalent and non-equivalent proton. In simple aliphatic molecules, just see here, it is what? It is the structure of ethane. It is, you have to pass a molecular axis or axis of symmetry. Axis of symmetry, it is nothing but axis of symmetry. That is, you have to pass a line which bisect your molecule into two half and check if your left hand side is exactly equal to your right hand side, then all the protons, that is hydrogen on this carbon atom and this carbon atom, are equivalent. That is, if your left hand side matches with your right hand side, then we simply says that these protons are equivalent proton. So number of signal we obtain in ethane is 2. Just replace one of the hydrogen from this molecule with bromine. Now cut this molecule into 2 equal half, that is passing a line from the center of the molecule. Here we see that your left hand side not matches with your right hand side. So it simply means that proton on this carbon atom is different from proton on this carbon atom. So this molecule give two signal because there are this molecule give two signal because there are two different types of proton is present. Again, this molecule that is in ethane pass a molecular axis from your center of the molecule. If your left half is equal to your right half, then protons are equivalent. Equivalent proton give single peak, therefore ethane give single peak. Just replace one of the hydrogen with bromine. Again draw axis of symmetry. See here, your this left half is not matches with your right half. Therefore, the proton which are present on this carbon atom is not equal to proton, is not similar from this proton. Therefore, they give different signal. So we got two signal here. Now, how many signals we obtain in propane molecule? Again, pass axis of symmetry. See, this left matches with this right. So this proton are equivalent proton, but at the same time the axis passing through this carbon atom also have a proton on it. Therefore, this proton is considered as different proton or non-equivalent proton. That's why propane is also give two signal. Just see this molecule. Pass axis of symmetry. Left hand side matches with right hand side. So these protons are equivalent. So this molecule give only one NMR signal. Again, just see this molecule, that is acetaldehyde molecule. Pass axis of symmetry from this carbon atom. What we see that left hand side is different from your right hand side. So we got two NMR signal in this molecule. Just we are going to make molecule little bit complicated. Again, pass molecular axis from center of your molecule. What we see, left hand side matches with your right hand side. So these protons are equivalent. While carbon atom axis is passing through carbon atom, it also have a proton. That's why it is non-equivalent proton. So we got two signals here. Likewise, we see our this chart. So what we go, we pass symmetry axis from ethane molecule from center. Left hand matches with right hand. Number of types of proton, that is only, they are all equivalent protons, so it is only one type. Number of signal is 1. Same molecule cut into half. Left hand does not match with right hand, so number of types of proton is, there are two types of proton, so we got two signal. Just see this molecule. Pass axis of symmetry from this. Left hand does not match your right hand. So this proton we denote it with A. This is with B and this is with C. So there are three different types of proton in this molecule. So we got three number of signals. See here, pass axis of symmetry from here and see, does your left hand side matches with your right hand side? No. So this is A, this is B, this is C, this is D. We got four number of signal. In ethyl alcohol molecule, pass axis of symmetry, we got three signal for three different types of proton. That is, OH also contains a proton, CH2 also have a proton, CH3 also have a proton, and all proton have different environment. So now we are going to see how to find number of signals in aromatic nucleus. Always remember that all the proton on the benzene are chemically equivalent. That is, they give only one signal in NMR. All protons are equivalent. But what happens when I replace one of the hydrogen with methyl group? Just like this. In this case, all these 5 proton of benzene give one signal, while proton on CH3 give another signal. So total number of signal obtained in this case is 2. One for 5 proton on benzene. One signal is for 5 proton on benzene, and one signal is from 3 proton on in 3 proton which are on CH3. Now what happens when I place any electron withdrawing group on benzene, like this molecule, that is acetophenone? In this case, since it is electron withdrawing group, this proton field de-shielding effect, this proton get de-shielded. So that's why they are going to give their different signal. That is, we can say that they are non-equivalent with respect to all these 3 proton on the benzene. So this CH proton on this CH3 give its own signal, one signal for CH3, one signal HB on benzene, and one signal for 3 hydrogen which are also on benzene. So in acetophenone we got 3 NMR signal. Next point is, what is position of signal? Before going to deep into this point, we should have to know what is meant by shielding effect and what is meant by de-shielding effect. Whenever a proton spin about its own axis, see here, this proton is spin around its own axis, it generates its own magnetic field. This is the magnetic field of nuclei. If the magnetic field of proton or a nuclei opposes the external applied magnetic field, then overall magnetic field, that is effective magnetic field, decreases. This effect is known as shielding effect. What is its impact in NMR spectra? Shielded proton always have lower del value. It also means that shielded proton have higher tau value in the spectrum. Now what is de-shielding effect? If the magnetic field of proton, that is induce magnetic field of proton, this is what induce magnetic field of proton, resonance force or parallel. When the induced magnetic field of proton is parallel with applied magnetic field, then effective magnetic field increases. In what? Effective magnetic field is increases. If the induced field resonance force with the applied field, the effective magnetic field increases and proton is called de-shielded proton. Now what is the impact of de-shielding effect? De-shielded proton, due to the de-shielding or due to the de-shielded effect, the proton value, that is proton got higher del value, that is del value of proton increases. In another word, we can say that tau value decreases. what is the meaning of chemical shift? The shift in the position of NMR signal due to the shielding and deshielding is known as chemical shift. The chemical shift is expressed in ppm and it is given by del ppm del V multiplied by 10 raised to the power 6 divided by V, where V is separation from TMS signal and V is oscillator frequency. Note that tau is equal to 10 minus del and TMS stands for tetramethylsilane, which is used as a reference standard. Now just see how the NMR spectrum look like. This is the rough idea of NMR spectrum. This is your y-axis, this is your x-axis. On x-axis, magnetic field value is plotted, that is denoted by del or tau. Any one scale can be used. So if del value is 10, to tau value is 0 from this formula. If del value is 9, this value is 1. That is, the order of value are in reverse order, and that's why we say that if a del value in deshielding proton, higher the del value, lower your tau value, and in shielding proton, lower the del value, higher is your tau value. Shielded proton, just see here, shielded proton have lower del values, that is, it means that it have higher tau value, while downfield effect or deshielding effect, the deshielded proton generally comes in this region, so it have higher del value, it means it have lower tau value. In next class, what is the importance of TMS, what are other factors affecting position of peaks, we are going to discuss that. Thank you very much.